Hello, we are the Weaver Monkeys, and this is our prototype for our 301 class. The way this prototype works is that hot, newly extruded 3D printer filament goes past the blue fan at the beginning, enters through the calipers, which measures its diameter, goes through the rollers, which is the primary way that the filament is pulled through the system. This pulled filament then enters the guidance system, and from there, the filament is wound onto the spool.
So when the filament enters our system, it first enters through these calipers. As you can see, the calipers are reading a diameter measurement. We zeroed it at 1.75 millimeters, so any number that it's reading is going to be however many millimeters off from 1.75 it is. As you can see, it's a little bit jittery, which did indeed cause us to have some issues. But the design was intended to read the signals from the calipers into its own Arduino, which was then used to send a signal to the other Arduino to control the speed of both the rollers, the spool winder, and the servo. The speed control was designed using a PID system, using the signal from the calipers for how off from the 1.75 millimeters it was, and adjusting the speed of the rollers using that. So that theoretically, if the diameter measurement was too large, it would increase the speed of the rollers, which would then stretch the filament more, making it a smaller diameter. This was then also used to adjust the speed of the spool winder and the servo, because between the rollers and the winder, we didn't want a lot of excess slack because we wanted it to be able to roll up nicely onto the spool. So as the speed of the rollers increases, the speed of the spool should also increase. The other thing that we accounted for was as the filament was wound onto the spool, it was increasing the diameter of the spool itself, requiring a slightly different speed for the spool to wind. So that was also changed using PID, so that as the filament wound onto the spool, it would slowly wind slightly faster to account for the different diameter. For the stepper motors, we used a pulley system to be able to increase the torque from the stepper motors that we were using to whatever we were driving with the pulleys. And this was because, based on our initial calculations, the torque that the motors could provide was not quite adequate. So we used a 2-to-1 pulley system, increasing the amount of torque while decreasing the amount of speed that they were going at in order to accommodate this. We use this on both of our stepper motors, which are a NEMA 23 for the larger one and a NEMA 17 for the smaller one. For the electronics, we ended up using a tire tread caliper to be able to measure the diameter, so that as the filament went through, it would increase the diameter measurement on the calipers themselves, which was then transmitted to an Arduino, which had a serial connection to the other Arduino, which transmitted that value that the calipers were reading so that the PID system could adjust the diameter based on speed for the motors. For the stepper motors, we ended up using a NEMA 23 for the rollers so that it could provide a decent amount of torque to adjust the diameter of the filament. For the spool winder, we ended up using a NEMA 17, which is smaller than the 23 because it ultimately didn't need to provide a lot more torque. It just needed to be able to spool properly. We also used a very large servo motor to be able to move the guide system back and forth so that it could wind evenly onto the spool. To power it all, we ended up using a 24-volt power supply, which we ended up using a 5-volt converter to be able to only provide 5 volts to the Arduinos, but provide the full 24 volts to the stepper drivers and also to the fan, so we could get maximum performance from the fan.